Hey everyone, it's Bradley Bush with another algebra video for you. Today we are talking about multiplying polynomials. Not just generally, but there's some special cases that have specific formulas that warrant a little bit of attention. Thanks for coming to my channel. If this is your first time, thanks for being here. If you're returning, thanks for coming back. If you enjoy it, please consider subscribing. Multiplying polynomials. Special cases. Let's start. So there's some special cases that look a little bit different. You can recognize them, you can learn to recognize them, and sometimes there's some formulas that could help you. Whether or not the formulas are always useful is probably just a personal preference. Sometimes I think it's just easier just to multiply out normal, because any of these special cases, you can simply just multiply and not have an issue. Multiply normally without using the formulas and get the same answer. So let's go through first with some examples where I don't use the formulas. I'm still multiplying these polynomials that have special cases, but I'm just doing it with normal multiplication. So you can see, and then we'll go back and we'll use formulas, and you can judge yourself whether or not you think they're useful. And actually, if you do think that you're, or you don't, I'd love to hear about it in the comments. So the first example here is to multiply a binomial that's squared. So 4x plus 3 quantity squared. When we're multiplying this out, we need to first realize what we have. And I need to stop right here because there's one thing that commonly happens here. I'm going to put it down here as a note. Not to do this. So it's very, very tempting when you have a squared, 4x plus 3 squared. It's very tempting to say, well, this equals 4x quantity squared plus 3 quantity, or 3 squared. But this is not the case. So I'm going to put a big yellow X in the equal sign there. We cannot simply square each of the terms. And the reason is because we have two things being added or subtracted together inside of our binomial. If we were multiplying, then yes, that would be the case. So, for example, 4x times 3, that whole thing squared does equal 4x squared times 3 squared. But that's different. You're multiplying 4x and 3, not adding them or subtracting them. So remember, we can't just apply the exponent. We have to do multiplication. Okay, let's go back to our... honestly, I think that's the biggest issue students have with these types of special cases. So let's go back to our problem. So we really have 4x plus 3. Whoops. 4x plus 3. And our exponent says there are 2 of them, right? So we have 2 of them there multiplied by each other. And now we just multiply. So when we're multiplying, we get 4x times 4x. We'll do, right? We'll multiply the 4 through everything. And then we'll multiply the 3 through everything. Just doing normal multiplication. Which gives us 16x squared, and 4x times 3 is 12x. 3 times 4x is another 12x, and then 3 times 3 is 9. And then when we are simplifying, the 12x and 12x give us 24x. So we have 16x squared plus 24x plus 9. That 4 doesn't look like a 4. There we go. All right. So that was pretty straightforward, right? I think the biggest thing was to recognize that the square on the binomial means you've got 2 of them and you've got to multiply them out. You're actually doing a multiplication problem and not just applying an exponent. So let's look at the second special case. The second special case has a negative. It's the same thing, but there's a negative. So we have 4x minus 3 quantity squared. So if we just do the same thing we did above, we have the 4x coming through to each of the terms in the second binomial, and the same thing with the negative 3. And what we get then is 16x squared minus 12x minus 12x and positive 9. Negative 3 give us positive 9 when you multiply them. So then we can simplify negative 12x and negative 12x give us negative 24x. So we have our answer there, but I'm struggling with my boxing. That was not super awesome. So very similar, but the middle term has changed sign. So what if we do 4x plus 3 and 4x minus 3? That is a special form because, and I have the special forms, by the way, out on the left in blue. So our first special form was a plus b quantity squared. The second special form was a minus b quantity squared, so something minus something all squared. The third form has the same thing, a and a b, but the signs change in between the a and the b. So we have a plus b times a minus b. This is a special form because you'll see the two middle terms drop out. So let's see what we have here. We get 4x and 4x give us 16x squared. And then, so again, we're just doing the normal multiplication. Let me draw my arrows really quickly. So we're doing the normal multiplication, and we have 3 and 4x is 12x, and then minus 12x, the 4 and the negative 3, and then 3 and negative 3 give us negative 9. We notice here that the 12 and the negative 12 cancel. So what do we get? Well, we get 16x squared minus 9, which is just a squared minus b squared. So that's interesting. It's kind of helpful, right? Let's do the next special form. The next special form is a plus b, so something plus something else, all raised to the third power. So remember, we can't just apply the exponent. This is actually a multiplication problem. And when we're doing the multiplication problem, we can see that we have 4x plus 3 multiplied by itself 3 times. Let's write them all out. So we have 1, 2, 3, 3 of them. Lucky for us, we have done a similar problem, right? Because if we look at this 4x plus 3 is the same thing as quantity 4x plus 3 squared, and we just solved that problem above. That's up in the top right. We have the answer for that. So let's just use that, right? Just to kind of make our life a little bit easier. So we're going to say this is the same thing as 4x plus 3. Actually, I'm going to change that. I'm going to put it somewhere else. Let's put it over to the right. So I have my first 4x plus 3 I'm going to keep. And the second 2 I'm going to replace. I'll put it in green so you can see. And we know the answer is 16 for 4x plus 3 squared. Above, 2 examples. We have 16x squared plus 24x plus 9. And now we can do our normal multiplication. So 4x goes into each of the second polynomial, and 3 does as well. So just multiplied, or just created my little arrows, and let's do the multiplication now. 4x times 16x squared gives us 64x cubed. And 4x times 24x give us 96x squared. 4x times 9 gives us 36x. And now let's change to the blue, and we get 3 times 16x, which is 48x squared. We have 3 times 24x, which gives us 72x. And then we have 3 times 9, which gives us 36. We can combine some stuff here. We can combine the x squareds because there's 96 here and 48 here. And we can combine the x's because we have 36 and 72, which gives us 108x. So let's do a little combining, and then we are done. Actually, if I just take this and move it over a little bit, I'll have some more room. So we have 64x cubed, and 96 and 48 give us 144 x squared. So we did the x squareds about the x's. Now we have 36 and 72, which gives us 108 x, and then we've got 36. And we are done. So multiplying that out, it's a little bit long, but it's not the end of the world, right? Let's try our last special form. So our last special case or special form is a minus b. So something minus something, all cubed, quantity cubed. And I'm going to do the same thing that I did before, meaning 4x minus 3 cubed, all quantity cubed, is just the same thing as 4x minus 3 times 4x minus 3 times 4x minus 3. And again, we know what this is, the 4x minus 3 squared, because we did that above. That's 16x squared minus 24x plus 9. So we will then just bring the 4x minus 3 down, and we can start our multiplication. Let's give ourselves a little bit more room because I'm going to draw the arrows, multiplication arrows. I don't want it to be too crowded. All right. So again, 4x and 16x squared give us 64x cubed. And then 4x and 24x give us negative 96 x squared. And then we have 4x and 9, which give us 36. Then negative 3 and negative 16x squared give us negative 48x squared. Negative 3 and negative 24 give us a positive 72x. And then the negative 3 and the 9 give us negative 27. Now when we're combining things together, again, we have a couple x squared terms. We have a couple x terms. We do, but I apparently left them out. This 36 should have an x. So let's add it. There we go. Now we're back rolling. And we can combine stuff. So we have 64, 64x cubed. We now have a negative 144x squared. and we have a positive 108x, and then we have negative 27. So doing the multiplication is very doable, but let's look at all of these again now just with the formulas and see. You can see for yourself, and again, please let me know in the comments if you think they're helpful or if they're not, because you know it's kind of an opinion thing, I think. So I have all of the formulas written out. You can see the formula, and then I have the answer that we got when we did the multiplication above also for each of these. So you should see that we get the same thing regardless of if we use the formula or not, or at least we should. If we don't, we know that I've made a mistake somewhere. The first thing we do is we identify the a and the b, because you know in our formula we have something plus something. So the a is 4x and the b is 3. So following our formula says that we have a squared plus 2ab plus b squared. We can just write that out. So let's do that. So we have a squared, so we have 4x squared plus 2 times a, which is 4x, times b, which is 3, plus b squared. And b is 3, so 3 squared. Now when we do our simplification, 4x squared is 16x squared. 2 times 3 is 6, times 4 is 24x. And then we have 3 squared, which is 9. So we got the same answer as we did before. No different. And, well, it looks like it was faster, right? I only took one line and then simplified. So who knows? What do you guys think? Let's do our next one. Our next formula is a minus b quantity squared, and our form is a minus b quantity squared, but our formula is a squared, and I've put the negatives in red so you can see, a squared minus 2ab plus b squared. So let's write that out. A is, again, 4x, and b is 3. So we have a squared, which is 4x quantity squared, minus 2 times a, which is 4x, times b, which is 3. And notice the b does not involve the sign, the negative. The negative is part of the formula. So negative 2 times 4x times 3, and then we have plus b squared, so plus 3 squared. Now we just simplify here. 4x squared, for quantity, 4x all squared is 16x squared. Here we have negative 24x, and here we have 9. So again, one step. I don't know. I go back and forth. It looks faster, but you know, honestly, doing the multiplication in my head is pretty fast too. Our next formula again was the a plus b, a minus b, and our formula to figure out what that is, to do the multiplication, is just a squared minus b squared. This one I think is easier, for sure. Faster. So a is 4x, b is 3, so we get 4x quantity squared minus b, which is 3 squared. And that gives us 16x squared minus 9. So I think that one is much easier to see, that it's just fast if you recognize the form, a plus b, a minus b. Next, a plus b quantity cubed. Our formula for multiplying that out is a cubed 3a squared b, 3ab squared, b cubed. And a and b again are the same. So let's see how this one goes. This formula looks a little bit bigger, right? So so we have 4x cubed plus 3 times 4x, which is a squared, times b is 3, plus 3 times a, which is 4x, times b squared, plus b squared, b cubed. Now, let's do some simplification. Simplifying here, we have 4x cubed. 4 cubed is 64, and then x cubed is x cubed. So we have 64x cubed. Plus we have 4x quantity squared, so that's 16x squared. And 3 and 3 is 9. 16 times 9 gives us 144. X squared. Then our next term, we have 3 squared, which is 9, times 3, which is 27, and that's times 4x. 27 times 4x gives us 108x. And then 3 cubed is 27. And that is the same thing that we got above. It's definitely looks cleaner, but you've got to remember all these formulas. So who knows? Let me know what you think. Our final one, we have a minus b quantity cubed, and our formula for multiplying is very similar to the positive case, but we have a couple negatives. So we have a cubed minus 3a squared b plus 3ab squared minus b cubed. So let's write it out. A and b stay the same, 4x and 3. So let's write this out. We have a cubed, so we have 4x cubed minus 3 times a squared, 4x quantity squared, times b, which is 3, plus 3 times a, which is 4x. It's not a very good 4x. Let me try that again. And then b squared, and then minus b squared, which is b cubed, 3 cubed. All right, let's do some simplifying. And we get 4x quantity cubed is 64x cubed. Our next term, 4x squared is 16x squared times negative 9 is negative 144x squared. And the next term, 3 squared is 9 times 3 is 27 times 4x is 108x. And then 3 squared is 27, and the negative makes it negative. So you can see we get the same thing as we had in the previous time we did it, the last time we did it, which we just multiplied out. So here are the special cases in polynomial multiplication. Sometimes it's easier. If you have the formulas, it might be easier. I think for sure it is in the case where you have a plus b, a minus b, but sometimes it might just be quicker if you don't have the formulas just to multiply it out using normal multiplication. Well, thanks for watching, and hope you enjoyed the video. Hope it was helpful, and have a good day.